Hey everyone, I'm Mr. A, and today we're going to talk about trigonometry. Now this is part one of a multi-part video series. This is going to be just the very basics to introduce you to what trigonometry is and the first couple of problems that we can solve with it. You're going to need a calculator with those three buttons, sine, cosine, tangent. If you don't have one, a good website you can use is desmos.com/scientific. That'll pull up this calculator right here. It's got the sine, cosine, tangent buttons right there. Back to the basics here. You might have thought that was sin, cos, and tan, but they're actually short for, sin is short for sine, cos is short for cosine, and tan is short for tangent. Now, we do call tan, tangent, tan for short. Cosine, we'll say cos for short, and sine, well, sine is about as short as it gets, but we don't say sin, it's sine. So please make sure that's sine, cosine, or cos, and tangent, or tan. Before we get into what sine, cosine, and tangent are, we need to do a quick review of functions. Last year in algebra you would have seen functions like this, and you may have talked about a function being an input-output type of device. The x, that's the input of this function. You put in some number, and then you generate some sort of output. This idea of an input-output machine is really handy to think about. This is how all functions work. There's some sort of an input that goes into the function creates an output. So again, for this function, if we were to input 5, then that x would become a 5, and it would be 2 times 5 plus 4, which would output the number 14. So we would say that f of 5 equals 14. This should all be reviewed from you for last year. The reason I'm bringing that up is because these three new things, sine, cosine, and tangent, these are trigonometric functions. That's actually a pretty cool word, trigonometric functions. So sine, cosine, and tangent are functions, which means they have the same input-output idea. You have an input to them, and then the function happens, and it generates some sort of an output. The difference is, with sine, cosine, and tangent, the input is always going to be an angle, and the output is always going to be a number. And in fact, it'll always be a number in between -1 and +1. Now these funny looking symbols here, you pronounce that as theta. It's a Greek letter, theta, and it's just kind of like an O with a little belt that goes left to right there. So we often use this symbol for angles in mathematics. You could use an X or a Y or a Z or an A, it doesn't really matter, but we tend to use thetas when we're using sine, cosine, and tangent. So what these three trigonometric functions are ratios, right? So they're actually a ratio of parts of a right triangle. That right triangle is important. So this only works in a right triangle. So in order to talk about the sine or the cosine or the tangent of some angle, we need to have a right triangle, and that angle has to be inside of the triangle. If I wanted to talk about the sine of theta, well, if this is the angle theta, then the sine of it is simply the ratio of the opposite side of the triangle over the hypotenuse. If you find the right angle and you look across from it, that's always going to be the hypotenuse. The opposite and the adjacent, right? So these are the other two words you see here, opposite and adjacent. These two we have to be a little bit careful with. The hypotenuse is always the hypotenuse. It's the angle across from the right angle. But the opposite is in reference to this angle. So what that means is if I find my angle theta and I look across from it in the triangle, that's going to be what we call the opposite side. The remaining one, the one that's next to the angle, is the one that we would call the adjacent side. You can imagine that if I were to put theta over here, this would be the adjacent, and this would be the opposite. So you have to pay attention to where the angle is in the triangle to understand which sides are the opposite and adjacent sides. Now these three ratios you have to memorize. So there's no shortcut here. You just kind of have to remember them, and you can't understand them because they're just chosen the way they are, right? Like I can't prove why we call a water bottle. That's just the way it is. So we need to know that the sine is the opposite over the hypotenuse. So I'll show you the way that I was taught to remember this. It's pretty handy. It's stuck in my head all these years. I remember this phrase, Sohcahtoa. Right? Sohcahtoa. I don't know why, but for some reason this seems to stick in your brain. It's a little bit of a brain worm. So Sohcahtoa is sine is the opposite over the hypotenuse, right? That's that ratio there. Sine is opposite over hypotenuse. Cosine is the adjacent over hypotenuse, adjacent over hypotenuse. And tangent is the opposite over adjacent, opposite over adjacent. Another way that you can write this that really pushes home that it's a fraction, so Sohcahtoa, and then you see sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. Now what's cool about these ratios is that they never change. So the sine of an angle is the same regardless of what right triangle that angle is in. Let me explain quickly why. Let's say I take this triangle here, has a 20-degree angle and a right angle, which means the other angle has to be 70. But the thing is, whatever the ratio of the opposite side to the hypotenuse side is in this triangle, it would have to be the same for any other triangle with a right angle and a 20-degree angle, because these triangles are all similar. And similar triangles have a property that the ratios have to be the same. If I make this triangle smaller, everything has to get smaller by the same scale factor, which means the ratio of the opposite to hypotenuse is the same in the little version as it is in a bigger version. So why do we care about these ratios anyway? Well, since they don't change, they're the same for any triangle, any right triangle that is, then if I have a right triangle and I have, say, a 27-degree angle here, and I have this side is 5, and I wanted to know what's the length of this side, I can actually figure that out. Now take a minute to realize that you could not figure that out at the moment. We need something else, right? Pythag won't work because I don't have this other side. But here's what I can do. I can say to myself, well, if this is the angle I'm talking about, then this is the opposite side, right? The one that is across the triangle from it. And this, of course, is the hypotenuse. So which of those three trigonometric functions can I use with an opposite and a hypotenuse? Well, that would be sine. The sine of an angle is the opposite over the hypotenuse. So I can say the sine of 27 is the opposite side, 5, over the hypotenuse, x. Well, that, if you put the left-hand side over 1, is a proportion, and you can simply cross-multiply and solve. X times the sine of 27 is equal to 5. And if you divide both sides by sine of 27, you get x equals 5 over the sine of 27. So if you pick up your calculator and you can just type in 5 over the sine of 27, 11.013. Now, if your calculator is in what is known as radian mode, then you will get approximately 5.22. This is no bueno. If you get 5.22, then you're going to look on your calculator for a button that says mode, and then tap that button, and it should say radian somewhere. What you want to be is in degree mode. The reason for this is simply that our angle was in degrees. That was 27 degrees, so we want to be in degrees with the calculator. When you're in degrees, try it again. Type 5 divided by the sine of 27, and you should get 11.013. Let's take a look at another one. We've got a 37 degree, and 12 is the hypotenuse, but this time let's say we want to find this side. We want to first figure out what parts of the triangle are what. So across from 37, that would be the opposite. Across from the right angle is the hypotenuse, which means this is the adjacent side. So I have an adjacent and a hypotenuse. So which of those three can I use? With an adjacent hypotenuse, that would be the cosine. Cosine is the adjacent over hypotenuse. So I can write the cosine of 37 is x over 12. Again, I can put this over 1 to cross multiply. I will get 12 times the cosine of 37 equals x. And if you are in degree mode, you should get approximately 9.584 for that one. All right, let's look at another example. Again, the first thing I'm going to do is locate my angle, and across from it would be the opposite side. The hypotenuse is the one across from the right angle, and then the adjacent side is the missing side, or the one that's next to the angle in between it and the 90, either way. So this time what we have is an opposite side and an adjacent side. So which of those three trigonometric ratios can we use? That's right, tangent. Tangent is the opposite over the adjacent. So we can say the tangent of 43 equals opposite x over adjacent 12. We're going to put that over 1 and we'll cross multiply, giving us x equals 12 times the tangent of 43. So you're going to take your calculator, type 12 times the tangent of 43, and you should get approximately 11.190 for that one. Just going to do a few more examples for you here. First, identify your angle, look across from it. That's going to be what we call the opposite side. The hypotenuse is the one across from the 90, and the remaining side is the adjacent. So I have here an opposite side and an adjacent side. That's going to be tangent again. So here I would do the tangent of 37 is equal to opposite x over adjacent 14. Putting this over 1, I can cross multiply, and that will give me x equals 14 times the tangent of 37, which gets me to x is approximately 10.550. All right, so again, I find my angle. Across from it is the opposite side, which I do not have this time. The hypotenuse is across from the 90, and the remaining side is my adjacent. So this time I have a hypotenuse and an adjacent. So which of those three can I use with a hypotenuse and adjacent? That would be the cosine. Cosine is the adjacent over the hypotenuse. So the cosine of 73 equals adjacent 11 over hypotenuse x. I will again put this over 1 and cross multiply. So here I get x times the cosine of 73 is equal to 11, which means x is 11 over the cosine of 73. And you should get approximately 37.623. So let's go with 37.623. One more simple one, and then I got a little bit something different for you. So again, we're going to find the angle first. Look across from it. That's the opposite side. The hypotenuse is across from the 90, and the remaining side is the adjacent side. So this time we have an adjacent and a hypotenuse. So that is, once again, cosine. Cosine is the adjacent over the hypotenuse. So the cosine of 17 is the adjacent 13 over the hypotenuse x. Putting this over 1, we can then cross multiply, giving us x times the cosine of 17 equals 13, which means x is 13 over the cosine of 17. You're going to type that into your calculator just the way you see it, and you should get approximately 13.594 in this case. So in this last one, we've got a triangle with not one but two variables. Well, don't let that throw you. You're just going to pick one variable at a time to work on. So let's first begin by finding our angle and looking across from it, denoting the opposite side in the triangle. Then this is the hypotenuse across from the 90, and this one, of course, is the adjacent. So let's say we're going to go after y first. We have the opposite side. If we're going after y, then we want the hypotenuse. With an opposite and a hypotenuse, we can use sine. Sine is the opposite over hypotenuse. So the sine of 25 is opposite 12 over hypotenuse y. We can put that over 1 and cross multiply. We get y times the sine of 25 is equal to 12, which means y is 12 divided by the sine of 25. We're going to pop that into our calculator just the way it looks. We should get approximately 28.394. Solve for z. So z is the adjacent side, and I still have this 12, which is the opposite. Well, with an opposite and an adjacent, I can use tangent, because tangent is the opposite over adjacent. So I can say that the tangent of 25, still the same angle, is the opposite side, 12, over z. I can put this over 1 and cross multiply, giving me z times the tangent of 25. Be careful with your z's. Sometimes they look like 2, so I'm going to put a little bar on that one there. Z times the tangent of 25 equals 12. If I divide both sides by tangent of 25, then I will get the z is equal to 12 divided by the tangent of 25. And if you plug that into your calculator, you should get approximately 25.734. So that's really all there is to this basic trigonometry. Sine, cosine, and tangent are all just ratios in a right triangle. Because all right triangles are similar, these ratios will be fixed for any specific angle. So if we have a 27-degree angle, we can say with confidence what the sine of that 27-degree angle is, or the cosine, or the tangent. Our calculators are able to calculate these for us. However, there are certain angles for which we can work them out ourselves, and we'll look at that in another video. If you enjoyed this video, please give it a like, subscribe to my channel, feel free to leave a comment below, and as always, have a great day.